now let's look at this question. Question 4. Question 4. For the following parabola, write down their equations in the form of y equal to a bracket x minus h close bracket square plus k. Okay, so first of all, we have to know this form is the form that has been completed the square. Okay, so it has been completed the square. So after completing the square, we can get the turning point straight away from the bracket as well as the part at the back of the bracket. So how to get turning point is we let the bracket equal to 0, then we get x equal to h. So try to imagine that. Okay, x minus h equal to 0, then we bring the h to the right, then we get x equal to h. So, but for the part that stay behind of the bracket, we have positive k. So y equal to k. Y equal to k. And once you get the x and y, they are known as the turning point. They are known as the turning point, which is h and k. H and k. Okay, so this form will help us to get the turning point straight away. But what we need to do now is they are giving us turning point. So they are giving us turning point, and you have to put it back to this form to get your h and k straight away. And of course, after you do that, and then you have to find a also. And to find a, you have to use other information other than turning point, like here the y-intercept. This will help you to find a. Okay, so let us practice the first part that I mentioned just now. So if they give you a turning point, so how are we find out the h and k so that you can put it into the equation? So we just need to bear in mind two important information here. The first one is the x coordinates. When they come to the equation, they will change sign. They will change sign. As you can see, initially the turning point take positive h. When I put into the equation, they will change to minus h. They will change from plus become minus. If let's say the turning point is negative, then it will become plus here. Then they will change sign. Okay, the second important properties, let's say I put it in green color. So h, after I bring it back to the equation, it doesn't change sign. Okay, the sign remains. It doesn't change. Okay, so the x coordinate, the sign changed to the opposite, but the y coordinate, the sign remains. Okay, so now what we are going to do is we have to work out the equation. Okay, so we do it like this for a. So as you can see, the turning point is 2, 3. It's 2, 3. Yeah. So when we write into y equal to a, x minus h square plus k. So just bear in mind, if the x is 2, as in here, then when you put it here, it will be x minus 2. Okay, it will be x minus 2. You can see it changes sign. Okay, so from positive 2, it becomes negative 2. Changes sign. But the y, it doesn't change sign, so it remains as positive k. I mean, if this is 3, then it will remain as positive 3. Okay, positive 3. So like this, and then we get the h as well as the k. Now we have to make use of this information 7 and find a. So how to make use of this y-intercept? We have to use it as a pair of coordinates with x and y values. So we substitute the y-intercept just now, the 7, right, is in fact having a coordinate of 0, 7. So when you use it, you have to use it together with the x as well as the y. So the y is 7. Substitute into the equation. That means here, the y, I change to 7. And the x here, I will change to 0. This a remains. So the x 0. Then plus 3. And after that, we have to keep doing. So 7 equal to a. Okay, so this part I just count it straight away. 0 minus 2 is negative 2. Negative 2 square means negative 2 multiplied with negative 2. That is positive 4. So I write down first, it is positive 4. 7 equal to 4a plus 3. And we bring the 3 to the left. So we will get 7 minus 3 equal to 4a. 7 minus 3 is 4. 4a. So a equal to 1. What happened is I bring the 4. The 4 is multiplying with a over here. So I bring it to the left, so it becomes divide. So when you divide 4 divided by 4, you get 1. So once you get a equal to 1, right? Now you put it back here. Put it back here, which is 1. So if you put 1, of course it looks a bit weird there. So if it is 1, just ignore it and no need to put anything. We just write like this. Y, straight away, no need to write 1, straight away bracket x minus 2 square plus 3. So bracket is not required. Okay, so we put it in this way, and that's all. Okay, the equation is just like this. Okay, now let's look at B then. Okay, B. Okay, so for this time we have turning point minus 2. Minus 2. Okay, minus 2. Okay, so the turning point is minus 2, 0. Minus 2, 0. The y coordinate is 0. Okay, so now we put it into this quadratic function again. Okay, so like what I mentioned, if this is minus 2, you put it here, it will change sign. From minus 2, it becomes plus 2. Okay, so I write down y equal to a x plus 2 square. So you can see it changes sign from minus 2, and when it comes here, it becomes positive 2. And then the y coordinate, which is 0, it doesn't change sign, so it will remain as positive 0. So imagine it is plus 0. Okay, it's plus 0 at the back, plus 0. Okay, so but the thing is, if you put plus 0, the quadratic function looks a bit weird. So plus 0 means nothing. So end up with this straight away. And then we want to find A. So again, we make use of the y-intercept. This is the y-intercept, 0, 4. 0, 4. So we do something like this, you know. So we substitute. We substitute 0, 4. And we have to find the A. Okay, so when we substitute, just remember the y is 4. Okay, so the y is 4. A is the unknown. And then x is 0. 0 plus 2 square. And then we count the bracket. 0 plus 2 is 2. 2 square is 4. So A equal to 4 divided by 4 is 1. So we get 1. So at the end, we write it as y equal to, okay, so imagine you put 1 inside here or here, 1. Writing 1 in front of the bracket makes the equation looks weird. So we don't write 1, we just write bracket straight away. So it automatically means 1 is in front. So we just write x plus 2 squared, and that's all. Okay. Then part C. Okay, so part C, let's take a look. Part C, the turning point is here, which is the origin. The origin, the origin is the turning point. So the turning point is 0, 0. 0, 0 is the turning point. So now y equal to a x minus h squared plus k. Okay, so the x is 0. So when you put it here, it will change sign. So it becomes minus 0. You may write it out, or you may straight away ignore it, like here, x minus 0. Okay, so I say it can ignore because x minus 0 is just x. So minus 0 doesn't mean any changes here. So likewise, the y coordinate will affect the k, but we don't change sign. You know, if this is 0, then you just put plus 0. And again, plus 0 over there is also meaningless. So we can just ignore the plus 0 or the minus 0. So it end up with, so imagine if I have x minus 0, so it end up with x only, and then the square still remain, and then the plus 0 at the back, you can just ignore it. So at the end, we get y equal to ax squared. So now we want to find a, and as you can see, we need to substitute coordinate. Okay, so substitute what coordinate? Let's say 1, 2. 1, 2. So this is the only coordinates given other than the turning point. Turning point cannot be used anymore. So we use other coordinate, 1, 2. So substitute 1, 2. And the way to substitute is the y is 2. Okay, the y is 2. The x is 1. A remain unknown. So 2 equal to a. Now we get the values of a, which is 2. And we pull it back here. Your a is 2. So we get y equal to 2x squared. Okay, so settle. Calculate the surface area and volume of this prism to 1 decimal place. Okay, so our question wants us to count 2 things. The first thing is the surface area. The second thing is the volume. So let's start from surface area. So for the surface area, what we need to do is we need to add up all the surface. Okay, so what kind of surface we have here? So for example, we have the curved surface on top, which is curved. We have the semicircle at the front and the back, and then the rectangle in front and back, and then another rectangle. I mean, this is left and right, so front and back, another rectangle. At the bottom we have also one more rectangle, so we have plenty of surface to to add up. Okay, so now let's start from the surface area. Surface area. Okay, so I start from the left. The left. The surface on the left is 20 multiplied with 15. As you can see, this is a rectangle, 20, and the height is 15. Where I bring the 15 here and count it 20 times 15. So that's the surface on the left. And surface on the right will be the same value. Surface on the right, as you can see, this surface, the bottom is 20, here is 15. 20 times 15. Surface on the right will be that also. Okay, so then I just times 2 straight away. It will save the time. So surface on the left plus surface on the right will be that calculation. And let's say I add up with surface at the bottom. Surface at the bottom. Yeah. Surface at the bottom, let's take a look. We have 40 and we have 20. So this rectangle will have a surface area of 40 times 20. So let's write down 40 times 20. This is the bottom, and we also have the semicircle on the left and the right. Okay, so if you have two semicircle, it end up with it is one circle. Two semicircle add together, that is one circle, and the area of circle is pi r square. Pi r square, pi r square. So you have to bear in mind also the pi r square. The r is radius. The radius is 10. So as you can see, the whole line is 20, right? That's the diameter. So half of it is 10. Half of it is 10. So pi r square. So we have pi 10 square. Pi 10 square. So this will be the semicircle on the left and right. Okay, plus, okay, we also have a curved surface on top. The curved surface, first we need to find out the length from here to here. The length. This is the circumference. We call it circumference, but it's just half of it. Circumference is 2 pi r. 2 pi r. So half of the circumference is pi r. Pi r. So that particular curve is pi r. Then you have to multiply with the length, 40. Multiply with 40. So why we have to do so? Imagine this is a curved surface, so you can flatten it and it become a rectangle. Okay, so that is I label it first. The curved surface on top. Curved surface on top. So if I go and count it, then it will be pi r. R is 10. Pi r multiplied with 40, because it is a rectangle then. Okay, so then we just add up. Okay, the first term, 2 times 20 times 15, so I get 600. The second one, the bottom, 40 times I think I left out one. Front and back. Front and back I left out. Front and back. Okay, so which means I left out 40 times 15, the front surface, and the back surface, which is 40 times 15 as well. Okay, so that is going to be 40 times 15, and that is the front surface. The back surface will be the same, so I times 2. Okay, so let's continue. Just now where we stop is the bottom, 40 times 20. 40 times 20 is 800. So 800. The front and back, 40 times 15 times 2, that is 1200. This is the front and back. Then we have pi 10 square. Pi times 10 square. So we get, we remain it as 100 pi for temporarily. So we change to 1 decimal at the end. So the last term, the curved surface is 400 pi. Okay, so if we add up everything, we get 2600 plus 500 pi. And we have to put it in 1 decimal. So we use calculator to help us. We just press everything. 4170.8 meters square. This is the surface area. And then we quickly go through the volume also. Volume. So volume. So to find volume, right, we just need to find out the area of the cross-sectional area, which is this one, then multiply with the length. Okay, so area is the cross-sectional area. So that cross-sectional area is the one in blue. It is made of a rectangle, 20 times 15. 20 times 15 plus the semicircle on top. Semicircle, the area is pi r square over 2. So which is pi times the r is 10 over 2. This whole part I put in square bracket. This is the cross-sectional area. So I just need to multiply this with the length. The length is 40. The length is 40. So multiply with the length. Cross-sectional area times length. This is the formula for prism. So when we do so, then we will get the volume. So let us count it out straight away. The cross-sectional area times 40. Then we get 18283.2 meter cube. So this is the volume. Okay, so we get the volume now. This is the value.